Hey class, Alec here. I hope you're doing fine today. We're going to start off talking about production, and then in the next lecture, we'll talk about costs. And in the third lecture of this series, we're going to put everything together and have a cost model of the firm. So today, let's look at production. I just want you to think in general. We're talking about the outputs that a business can produce depends on the inputs that they use. Let's think about the factors of production. The factors of production, you recall, this is just a review, are equal to land, labor, and capital. Enter in time horizons as we think about the factors of production. In the long run in economics means that you're in the pre production phase. You're thinking about going into a business. You're trying to make an investment decision. In the long run, imagine me trying to open up my dahlia farm. I'm sitting around the kitchen table. I'm doing research on dahlias. I'm doing research on the square footage of land that I need and the materials that I need and the tools and equipment that I need. I'm looking at my finances. I haven't decided to do anything in the long run. As we go back in the long run, therefore, all of your factors of production or your inputs are variable. Your long run production function would say this: Q, or output in the long run, depends on your land, labor, and capital. Everything's up for grabs, so it's included in my general functional form. In the short run, so I go from the kitchen table to making phone calls, buying equipment, getting into the dahlia farming business. In the short run, I am now more concerned about my output decision because I'm in the production phase of my business. I've decided on my business model, if you will. In this case, I've decided on the amount of square footage that I need. I've decided on the equipment that I need. Am I going to buy a tractor? How many shovels? How many gloves? How much fencing, etc. The only thing that I can change, and this is important, the only thing that I can change in the short run is the amount of labor that I employ. That is my variable input. So now you can see the short run production function over here to the right. It says the output that you can produce in the short run depends on the amount of labor that you hire, dot, 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 given your choice of land and capital. And that's where our friend ceteris paribus comes in. So in the short run, we're effectively holding this and this constant. The only thing that you can change in the short run is the amount of workers that you employ. So let's look at a short run production function. I have a short run production schedule down here to the lower left. And in the first column, as you can see here, is the number of workers that I hire. The second column is the output that I produce. And then the third column is the marginal product associated with each worker, and I'll talk about that in a second. But let's look at the first column here. Obviously, if I don't hire any workers, I can't produce any output. So I'll start at one worker, and then I'll go to the second worker, third, fourth, fifth, and sixth worker. The output that I get from the first worker is equal to 10 units. The output I get, listen to the way I say this, from two workers is equal to 30 units. The total product or total output that I can get with two workers is 30 units. Likewise, if I have three workers, I can get 42 units. Now, the marginal product, this is where we're very interested in as economists because we want to look at the rate of change. We want to be very, very specific and look at a single point and be as precise as possible. This is using the tools of calculus. The marginal product of labor is equal to the change in total product when you hire one more worker. Okay? Another way to say this is how much output will you get if you hire an additional worker? So the marginal product here, now stop and think about this. We can sequentially look at the marginal product by going from row to row and then looking at this second column. So if I don't hire anybody, I don't get any output. If I hire the first worker, I get 10 units. Therefore, the marginal product of that first worker is 10 units. What's the marginal product of the second worker? The marginal product of the second worker is 20 units. I know many of you wanted to say 15 units. That would be the average product. That would be simply 30 divided by 2 equals 15. But the marginal product is looking at the change in output as you hire one more worker. See if we're getting it now. The change in output if I hire one more worker, the third worker, is 12 units. The change in output if I hire the fourth is 8. Now we've got 0 and then a -8. Clearly, are you going to hire that fifth worker? And the answer is no. Why? Because they don't contribute anything to output. So this could be called the point of saturation, and you're not going to go beyond that. I've taken the points, the first two columns, and I've graphed them over here to show you what the short run production function looks like. You can see that it starts out, let me get back to my wonderful colors, flat, steep, flattens, 0, and negative. It has this peculiar shape. So now imagine what happens, and I'll explain it to you, and there's really two things I want to talk about with respect to the production function. Short run production functions will always have this shape. In addition to these areas across that function, I want to highlight this point, this inflection point right there. So let me talk. Where it's flat, that's underutilization of labor. You have one person running around the dahlia farm doing everything. Okay, so I think to myself, well, why don't I hire the second worker? Does it make sense? Well, I can look back over at my production schedule and say, yeah, this first person is running around doing everything. If I hire this second worker, I get 20 more units of output. This blue area here is what they call specialization of labor. And it means this: the marginal product of labor is going up. Each additional worker gives you more and more output. Now in my example, I hired that second worker and my output goes up significantly, does it not? And it's because the two workers are dividing and conquering. One person is running the tractor and the other one is tending the soil. They split their tasks up based on their comparative advantages. One person is better at the tractor and the other one is better at working the soil. Maybe it's one person is better at working with doing customer service. This is the divide and conquer. Now notice what happens. They split up. They specialize in doing something that they do really well, and they reduce the amount of time moving from task to task. Okay, and more in a more dynamic sense, their efficiency, they get more knowledgeable about the tasks that they're doing and their productivity improves. So these are all kind of the background reasons for specialization of labor. You can see at some point here with the third worker, the curve begins to flatten. This point here is called diminishing returns. Output is going up, but the increase in output is slowing down, and that's the flattening that you see here. Okay, so we can look at right here. You know we get to 0. You can see that the slope of this function right here is 0, and between these two spaces, so output here is from hiring an additional worker is 0, and then it becomes negative. We have too many people standing around. Okay, now notice what happens. Every production function, I'm going to shade this in dark, and I want you to draw this out a couple times. Every production function has this peculiar shape. Kind of looks like a Nike swoosh. It's flat, where underutilization of labor is occurring. It's steep, where specialization of labor occurs. It flattens, where diminishing returns kicks in, becomes 0 at the top of this production function, and then negative at points beyond that. Okay, I hope everybody understands that. Let me go on and see if we can do this. Good. Let's test our understanding. What's the difference? Let's look at the top graph. What's the difference between these production functions? You have TPA, TPB, and TP subscript C. What's the difference? Obviously, you can look at this, and the first thing that you notice is there is an issue with scale, is there not? TPA is small, TPB is medium, and TPC is much larger. Why? Well, the answer is they all show or represent different investments in land and capital. Okay, A is small. Let's put it. I have maybe say 100 square feet of land, a couple shovels, and that's it. TPB is medium. I've got 1,000 square feet of land, small size tractor, and a couple shovels, and then TPC is large. I made a huge investment decision where I got 100 acres of land. I've got a huge tractor. It's got all the equipment, the advanced farming equipment. I've got a few shovels, but clearly I have a much larger investment decision. And you can see in this case that the gains from specialization are relatively small here. They get bigger for the medium-sized investment decision, and then they get much larger for that large investment decision. Diminishing returns kicks in here, here, and then here. Does that make sense to everybody? Let's look at this bottom one now. How do I, or if I don't want to do any side calculations, how do we measure the marginal product of each worker? Now remember, the marginal product is equal to the change in total product when you hire each worker. So I started off at 0 and I hired that first worker. Clearly here, the total product of the first worker is equal to the marginal product of the first worker simply because I started with 0. What if I hire the second worker? How much more output do I get? Well, here is your start point. You go up to this point on your production function. Therefore, here was the marginal product of the first worker. Here is the marginal product of the second worker. And this is equal to the total product of two workers, which is equal to the marginal product of the first plus the marginal product of the second. These two steps add up to TP2. So I said the term steps, incremental analysis. That's what the world of calculus is all about. And clearly you can get this last one here. This is where I start with the second worker. That's my total product. What happens to my output when I hire the third worker? It goes up by this much. Therefore, this distance here is the marginal product of the third worker. And of course, this is the total product of 3 workers, which is equal to the marginal product of each individual worker. We went from, here's our first step, here's our second step, and then here's our third step. Make sense? Good stuff. Talk to you later. Bye.